Hi everyone, welcome to Lesson 5. This is graphing sine and cosine functions for our trigonometry unit. So, basically this unit, or this lesson, we're going to graph our sine and cosine function. What it ends up looking like is it's going to be the sinusoidal curves, so it's going to be a curve of some sort. As basically how it works is as a point rotates around a unit circle, the motion is then going to graph itself out from a unit circle onto something more of a 2D shape. So, in this very first example, we have complete the following table and graph y cosine theta. Well, you have two ways to graph this. Option number one, you can graph it using the x values given here. And notice that the x values given in this question are 0 pi over 2, pi, 3 pi over 2, and 2 pi. These are all in radian. If you aren't too familiar with radians, you can definitely switch it back to degrees and graph the same thing in terms of degrees. Right away, what I'm going to do is pull up my graphing calculator and go y equals. On my graphing calculator, I'm going to type sine x, and that's going to be sine theta. From here, if I hit graph right away, let's see what happens. I get a nice funky curve. There we go. But notice that our domain says that we're starting at 0, so really I don't need any of this to the left, and I can probably zoom in on my graph a little. So on my graph here, I can change it between 0, and instead of 10, I can actually go to 2 pi. And we should probably go up by a scale of potentially either 30 or 60 degrees. If I go 30 degrees, it's going to be by pi over 6. And all the meanwhile, my mode, I should have been in radian, and I was. So I just changed so far my x values. My y values, let's keep it between negative 10 and 10. Actually, let's change it up. Let's scale it down a little. Let's go from negative 2 to positive. I forgot my negative button, negative 2 to positive 2 there, going up by 1, that's perfectly fine. Or really, we can go up by something smaller if it's that close. Let's go up by 0.25 to see if we can get as accurate as possible. Hitting graph now, that's our curve, and that's what we kind of want to graph out on our grid here. So our grid's between 0 and 2 pi, and going up the sides here, I got, if I use the same scale, if I use my same scale, my scale here, I'm going up by 0.5 or 0.25, so 0.25, 0.5, 0.75, and 1 at the very, very top there. So let's start sketching. Another way before we start sketching is we could fill in our table of values, and again that's straight off of our graphing calculator. How do I get to my table of values? Go second graph and I bring up a table of values. However, look at my x values. These do not match up to these ones over here. So I could change my x values so that I'm starting at, let's say, 0 actually. Let's start off at 0 and let's go up by pi over 6, which is 30 degrees. And if I go second graph again, even though these don't really make sense to me, I guarantee you they do match up. The one that does stand out to me, 3.1416, that's pi right there. Pi matches up decimal wise right there. So for my table of values, at 0, I'm at 0. At pi, if you notice that 3.14, I was at 0, and at 2 pi, let's double check 2 pi. So 2 pi is going to be double 3.14, so we're looking for 6.28. Let's scroll down. There we go. 6.28 is double of 3.14, so at 6.28 we're also at 0. At pi over 2, which is half of 3.14, which is about 1.57, is 1. And at 3 pi over 2, which is about 4.7, we're at negative 1. Alright, so our table of values is filled out here in terms of radians. Again, I'm going to try my best to sketch all these coordinates on here, so let's plot these first few here. So we have 0, 0. At pi over 2, we're at 1, and again, I'm going up by 0.50 on my y. So I have 0.5, 1 up top, 0.25, sorry, my scale was 0.25, there we go, 0.75 right there. just to fill in every square. So at 0, 0, at pi we're also at 0, and at 2 pi we're also at 0. But notice that in between here we have way more x values than we do over here. We could just fill those in soon after here. So pi over 2 we're at 1, and at 3 pi over 2 we're at negative 1. And again, I should have filled in a negative 0.5 right here, negative 1 here, of course negative 0.25 right here, and negative 0.75. There we go. So we only have 5 coordinate dots right now. We do want to fill in the rest of these as best as we can. So again, I'm going to my graphing calculator, and because I went up by 30 degrees, aka pi over 6, I have all these coordinates here. So around x equals 0.5, we're also at 0.5. So there we go. And because this is sinusoidal, it's going to pair up, it's going to match the same. There. Our next coordinate here is at 1.04 and about 0.8586 there. And so that's the next one over. 0.75 is right here, 1's here, so halfway basically between the two. That's going to be 0.85 as best as we can. And again, that's just going to mirror on the other side. Going down, we got to 0.5, negative 0.5, 0 at pi. The next one should have been negative 0.5. So 0 at pi, negative 0.5 right here. Again, that's going to mirror right over here. And the next one after that, negative 0.85. Oop, I'm off by 1. It's going to be right here and right here. There we go. So now I have enough coordinate dots to sketch a graph, so that's what I'm going to do, and this is going to be a free-handed sketch. And there you go. So I sketched it on. Of course, this graph does continue on in both directions, because if you really zoomed out, you do have way more than just this graph here, but this is our sine curve. So key things about our sine curve. Our sine curve starts at 0. Our very first coordinate dot should be at 0. There's a peak up about a quarter of the way in. There's a valley about 3/4 of the way in. Halfway it has to hit at 0, and at the end it also has to hit at 0. So there's a few key features of your sine curve. You have two keywords here. The first one that we're going to talk about is period, the length of the interval of the domain over which the graph repeats itself. So if this graph started at 0, it goes all the way up and all the way down to pi. If it had done another up and then down, then that would mean that its period would have been from 0 to pi, because it started repeating. But in this case, it wasn't the same shape. It wasn't another part of a graph that's above the x-axis. It went below the x-axis. So my entire graph is going to go from 0 to pi, and because it hasn't repeated itself, it's going to go down, then back up to 2 pi. That's going to be considered what we call one full rotation for sine. So our period for sine, how many rotations do you have, and how long is it? You have one full rotation where you have a hill and then a valley here. That's one full rotation, and it's going to start from 0 and ends off at 2 pi. So my period right now, 2 pi. Amplitude, meaning how half the distance between the max and the min values of a periodic function. Basically, your amplitude is if you take your maximum value, and in this case it's 1, the highest number we got to is 1, and you subtract it from your minimum value. In this case here, our minimum value is -1, so if you add 1 minus -1, that's +2, divided by 2, and that's just 1. So that means you are a distance of 1 away from your x-axis, and that's going to be the same down here to get to your max and to get to your min. So that's our amplitude. Number 2 says state the following for sine theta. So we want to figure out our amplitude. Again, there was an equation given to us, so I'm just going to plug everything into that equation. So it's the absolute value of your max minus your min. So our max was 1 minus off our minimum value, which is -1. All of that is divided by 2. And of course, 1 minus -1 is just 2, because this is absolute values, 2 over 2, which is just 1 ultimately. Our period here was between 0 and 2 pi, so our period is considered 2 pi. Of course, if you did this whole graph in terms of degrees, which you totally could have, our period then would switch up between 0 and 2 pi, or between 0 to 360. 360 degrees would be our period there. Our domain, how far left and right are we going? So if I go back in my notes and you already have your graph there. So as far left as we can go is basically, this graph is going to go on to infinity. As far right as we can go, well, this is going to go on to infinity. It's just that we ran out of graph here. So our domain, we could say something like it's between negative infinity, positive infinity, not including infinities. Arrange the lowest and highest we went. The lowest we went was -1. The highest we went was +1. And we do want to include -1 and +1 because we do actually have values at those coordinates. So at +1 and at -1 we actually have values there. Our y-intercept, well, where did this graph cross on the y-intercept? It crossed at 0, 0, the origin. And our theta intercepts, aka our x-intercepts, where did we find them? Well, we found the first one at 0, 0. The next one would have been at pi, 0. And the last one there would have been at 2 pi, 0. So those are all our intercepts. And again, our intercept was 0, pi, and 2 pi. So these here are our characteristics. It's pretty basic. Things that could have changed up if you did it all in degrees are period. Instead of saying 2 pi, we'd be 360 degrees. Domain and range are still the same. Y-intercepts are still the same. Our x-intercepts, the coordinates instead would be 0, 0, 180 and 0, and 360 and 0. Those would have been all our coordinates for our x, or for our theta intercepts, or x-intercepts really. In example 3, we have complete the following table and use it to graph y equals cos theta, and then complete the information. So same information as before. So again, everything's the exact same. The only switch up right now is instead of saying sine, we're just going to say cos. Hit graph, and here we go. So our graph, and I'm just going to quickly zoom in on our graph a little bit even more. So between -1, 1. There we go. That's our cosine curve right there. So it starts at the top and it drops all the way down, and it's going to continue going in this direction. Top, down, goes down to a valley, all the way back up, back to the top there. So hill to hill, basically. So let's sketch this out. So going second graph, I bring up a table of values. So we're going to want coordinates at 0, 1. So let's start there at 0. We're at 1. And yeah, we'll switch colors this time. At 0, we're at 1. Other key things. At 1.5, that's pi over 2. We're at 0. At pi, let's look for 3.14. 3.14, we're at -1. We're back to 0, I can bet, and we're back up to 1 over here. So there we go. We have about 5 coordinate dots. Of course, this is 1. This is about 0, or not 0, but this is positive a half right there. You had 0 here, negative 0.5 going down, and -1 there going down. Okay. Let's fill in some of the other coordinate dots, and again, straight off of our graphing calculator. We're at 0.86 and then 0.5 respectively for the next two. So 0.86 is right up here, 0.5 right here. So then the next one here should be 0.5 negative and 0.86 negative, and that's just going to repeat itself. And then we're done. And now we have more than enough coordinates to try to match it up. And so our graph, again, is going to look like this. And there we go. That's our cosine curve. And it does match up to our graphing calculator right here. Let's fill in some of these characteristics here. What's our amplitude? Well, basically, again, you have an equation, or if you can ask yourself, how far away are you from this midline there? But let's just figure out our amplitude using our equation. So it's the absolute value of our max, which is 1, minus our min, and our min was -1. Under absolute values, all of that divided by 2. So again, you have 2 over 2, which is just equal to 1. To mean as far left and right as we're going, well, this graph is going to go on forever, so negative infinity to positive infinity. Y-intercepts, yes, we do have 1. It's going to be at 1 comma 0. Our period, again, it's basically when this graph starts repeating itself. Well, it's starting at the top, going all the way down, 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 started going all the way up, 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 and back to the top again. So our period from top to top, 2 pi. And again, of course, we can always write 2 pi in terms of degrees, which is just 360 degrees if this question was done in all degrees. But for now, 2 pi. Range, how low, how high? Well, the lowest we went was -1. The highest we went is +1, so that's our range. Theta intercepts, aka x-intercepts, we only have 2 this time. It's at pi over 2 and at 3 pi over 2. And again, if you were working this question out in terms of degrees, your 2 degrees would have been 90 degrees and 270 degrees. If you'd done this question in all degrees instead of radians on our x-axis. So, in this next example, or this next set of notes, we have the following. So, transformed sinusoidal curve is written by this equation, or this one here. So you have one with sine, one with cosine. A, B, C, and D are basically A, B, H, and K. It's just that A, B, H, and K are now going to have fancy names because we're in trigonometry. Amplitude of a sinusoidal graph is changed by vertically stretching the graph. So therefore, it is changed by changing the which value. It's going to be changing the A value. So if you have an A value, your graph is being vertically stretched. Note here that A value is never, A value may be negative, however, amplitude is always a positive value, therefore amplitude is always absolute values of A. If you had a negative A value, that just means you have, again, a reflection over your x-axis there. Period of a sinusoidal graph is changed by the horizontal stretching. Therefore, it's changed by changing the, and the value we're looking for here, of course, is the B value, because again, vertical stretch, horizontal stretch, translation, and translation, but those two translations have special names. The period is influenced by the B value, but it is not the B value. So when we talk period, we're not talking the B value. B value is from your equation. Period is going to be this calculation here. It's either 2 pi divided by absolute value of B or 360 divided by absolute value of B.